Hello there, welcome to the show. I hope you are doing well. In the previous episode of the series, we discussed ethanol and ethanoic acids. Today we are going to discuss the attempts toward the classification of elements. So, let's begin the show. Before the development of the modern periodic table, several early attempts were made to classify and organize elements based on their properties. These early classification systems were significant steps toward understanding the relationships between elements. Here are some notable early attempts at the classification of elements. Döbereiner's Triad. Döbereiner's Triads, proposed by German chemist John Wolfgang Döbereiner in the early 19th century, were a set of groups of three elements that displayed similar chemical and physical properties. The triads were based on the concept that certain elements could be grouped together based on their atomic masses and similarities in the properties. While Döbereiner's triads provide an early attempt to classify elements based on their properties, they were limited in their scope and were later replaced by more comprehensive periodic table arrangements. Nonetheless, Döbereiner's triads played a crucial role in the development of our understanding of periodicity and the relationship between elements. Newlands Law of Octaves. Newlands Law of Octaves, proposed by English chemist John Newlands in 1864, was an early attempt to classify elements and identify patterns in their properties. The law was based on the observation that when elements were arranged in order of increasing atomic number, certain properties repeated every 8 element, similar to the octaves in music. Despite its limitations, Newlands Law of Octave contributed to understanding of periodicity and the need for organizing elements based on their properties. It played a crucial role in the development of modern periodic table, which is based on the periodic law and the arrangement of elements according to their atomic number. It's important to note that while Newlands Law of Octave had shortcomings, it represented an important step in the evolution of our understanding of the periodicity of elements and laid the foundation of subsequent advancement in the field of chemistry. Meyer's periodic table. Meyer's periodic table, developed by German chemist Julius Luther Meyer in 1869, was also an early attempt to classify elements based on their properties. Meyer's work on the periodic table was independent of Dmitri Mendeleev's, although they both made significant contributions to the understanding of periodicity. It is important to note that Meyer's periodic table, while influential, did not gain as much recognition as Mendeleev's table. Mendeleev's periodic table, which was based on atomic mass and incorporated predictions of undiscovered elements, became widely acceptable and formed the foundation of modern periodic table. However, Meyer's independent work on periodicity and the organization of elements by atomic volume played a significant role in the early development of periodic table concept. Mendeleev's periodic table. Mendeleev's periodic table, proposed by Russian chemist Dmitry Mendeleev in 1869, is one of the most significant achievements in the field of chemistry. It is an arrangement of elements based on their atomic properties and paved the way for the modern periodic table we use today. Mendeleev's periodic table revolutionized the field of chemistry by providing a systematic framework for organizing and understanding the properties of elements. It played a pivotal role in the advancement of chemical research and continues to be a fundamental tool for scientists in studying the behavior of elements and their compounds. Till now, we have discussed the different early attempts towards the classification of elements. That's enough for now. For more information about this or any episode of the series, check out the blog. Link is in the description. We have additional contents, further readings, and transcripts of every show. We have also published our books on Amazon Kindle Publisher. We would love to see your reviews over there. Thank you for coming to the channel and watching the video. I hope you loved the show.